Hello everyone, in this particular video we'll be talking about the LeakyReLU activation function in PyTorch. So let's open the documentation. As I said, torch.nn.LeakyReLU. In here we have basically two parameters. One is the negative slope and again in place equal to false, just like the ReLU. Okay, now let's quickly get into the function. So it's very similar to ReLU. There's only one minor change. Okay, so ReLU was just max of 0 comma x. Okay, here we add a slightly we had a small term which is negative slope into minimum of 0 comma x. So let me go and explain to you. So with the graph it will be very clear. Okay, so as you can see, let me show you the x-axis also. So from 0 onwards, that is on the right hand side, it is the same as ReLU, that is y equal to x. But in ReLU, for the negative values over here, we had 0. Okay, in case of LeakyReLU, we are not going to have 0, we are going to have a very small number. Now what is that number? That is going to be a negative slope, which would be a small number lesser than 1 into the value of that. So let's say over here this is going to be x. We will multiply it with a small negative value, or we'll multiply it with a small negative slope, or that is going to be a very small positive integer. And so positive integer into negative value is going to be a smaller negative value compared to the integer. So let's go to this part. So let's compare. Okay, so as I said, ReLU is basically on the left hand side, on the left side of the axis we had 0, and on the right hand side you have y equal to x. So in LeakyReLU, as I said, you are going to have the same thing for y greater than 0, x greater than 0 over here, x equal to 0 is over here. Okay, however, here on the negative side, that is for x less than equal to 0, we are not going to have like this. Okay, we are going to have a little bit of a bent over here, so something like this. Okay, so it's not y equal to x, it's going to be y equal to small number, let's say lambda into x. So lambda is what I'm saying as, no, it is not like this is for only for our interpretation. Okay, this is not mathematically called lambda, it's just said as negative, it's mentioned as negative slope. Generally you take it as a 0.1 or 0.01. We'll have to see in the documentation. I think it is let me just check. Yes, it's 0.01. So this is the default value. Okay, you can play with this number. You can also have 0.02, 0.03 or 0.005, whatever. Okay, you can play. This is a hyperparameter that you can change. So what is that going to do? It is going to basically going to change the shape. So for example, if you are taking 0.01, then this graph will look something like this. So let's have a straight line down over here. This is the y-axis, this is the x-axis. Right hand side is going to be the same. So let's say we are drawing for negative slope is equals to negative slope, that is what I called as alpha, is equals to 0.01. okay, so I'm not going to draw by scale, it's just going to be close like this. Now what if you divide this number by 10? Now if you divide this number by 10, obviously it will become so here it is the y equal to 0.01x for x less than 0, for x less than 0. Okay, now what if you divide by 10? So what if you say now negative slope here is going to be, instead of 0.1 is going to be 0.01. So your new equation is going to be y equal to 0.001x. okay, and the graph, if I can draw over here, the graph will look something like this. On this one only I'm going to show you. It's going to be closer, it's going to be closer to the x-axis. Now this is not a straight line, I am trying to make it a straight line, but I hope you get it. Okay, so the smaller this value is, the smaller the value of this negative slope, the smaller the value, the more it's going to reach towards the x-axis. Okay, so we'll start by first importing torch and torch.nn as nn, which is the basic import. Now this line is just for printing, you don't have to use this particular line. Okay, this is just to make sure that scientific notations are not printed so that we can easily interpret the results. So this is going to be your random value generation, torch.random10. So this is going to generate random values over here. You will see the generation. So there are, you can see random values have been generated. There are totally 10 numbers because we had specified 10 over here. Okay, so as you can see, there are some negative numbers over here, negative, negative. So they are mostly negative. Okay, but there are also positive numbers over here. You can see there is a positive number, there is a positive number, and these four are positive numbers. Okay, so let's now apply the LeakyReLU. So now we are going to apply the LeakyReLU nn.LeakyReLU, but we are going to keep the default parameters as the same, which means your negative slope is going to be 0.01 and in place equal to false. In place I'll explain in a second, but this is more important. Okay, so let's go and hit shift and enter. So as you can see, this particular number, it's a negative number, and when there was a negative number, it had to be multiplied by a negative slope. Instead of multiplying it by 0, or rather just substituting 0 as in case of ReLU, in LeakyReLU what you do, you multiply it with the negative slope. Negative slope was 0.01, which was the default. So basically divide by 100. So if you take this number and divide by 100, you will be getting this, right? This is also a negative number, so again divide by 100, this is what you will be getting. So all these are negative numbers, all of these numbers have been divided by 100. However, if you see the positive numbers has been just kept the same. Here again you can see the positive number, it is again the same. So all these positive numbers over here, they are basically kept same, as you can see over here. Now if you want to verify sometimes, let's say what is the negative slope, then you can just say nn.LeakyReLU.negative slope. It's going to give you that. Now let's say I don't want negative slope equal to the default negative underscore slope, the default. I don't want default, I want to reduce that number, or let's say increase that number. I want to multiply it by 10. So I'm going to say negative slope equal to 1.0. Now we are not changing rand, so which means this this particular tensor is going to be the same. Now let's hit shift and enter. Okay, what you are going to see now, this time this number is not divided by 100, this time this number is divided by 10, as you can see over here. Same thing again, all these values have been gotten from all these values after dividing these values by 10. Okay, now for the positive, they remain like that. Okay, so positive values over here, as you can see, these positive values are the same over here as well. So I hope you were able to understand this point. Now what is in place equal to false? Now if you have seen the video of ReLU, it's basically the same thing over here. So in place is basically your in place function in place function is basically let's say if it is true, which we mostly use, then we have less memory usage, that is less memory usage and higher speed, okay, of computation. Basically the way it is done is this actually changes the computational graph, changes the computational graph, which I don't want to get into right now. Okay, it changes the computational graph. Okay, so we mostly use in place equal to true until we get an error. If we are getting an error, then we change from true, we make it false. So that's the idea. So I don't have to, I don't think I'll be explaining more on this. I think it's very clear, simple. Okay, this is just the way of representing it. So if you like the video, please like and subscribe, and bye.